Now that we've set up the scene and brought in all of our assets, let's start prepping this building for fracturing. So let's go down and create a new section for prepping that building. So create a new geometry node. I'll call mine week 2 prep building. And then dive inside and we'll create an object merge. And we'll point that to our assets environment and then out destruction building A. And with our viewport options, let's hide other objects so we can only see what we're currently working with here. And in the last video, we took a look at selecting pieces and splitting based on the path attribute. And we're going to do that some more to isolate the sections that we want to deal with. Now, I pretty much always simulate the glass in secondary passes after we're done with our main RBD destruction sim. So we're going to start by splitting out all of the glass geometry. And it's pretty common for assets to be built with a string that indicates what material it's made of. So if we go to our selection by attribute with that icon there, or hitting 9, and make sure that we're selecting by alembic paths. If you select just one of these windows, actually it looks like everything is all grouped together here, you can tab and type split, so it splits out all that glass geometry. Now if you want to, you could just use the glass string that's embedded in the path here. If we go to the group, you can search through that parameter there, but I'm just going to click in it, hit Alt-E to bring up the string editor, and we'll expand that to see this entire path here. And you can see at the end, there's this GLS shape string. So if we just select everything that has underscore GLS in the path, just by saying at path equals star underscore GLS star, that's one way to grab all of the glass in this building. Your assets might not be set up this way, but it is very common in production to have some sort of material indicator in the names like that. So let's rename this to split glass, and we'll create a null so that we can grab this later from elsewhere in our scene. I'll call this out BLDG for building glass. And on the flip side, I'll create another null for non-glass geom. We'll name it as such, non-glass geom. And we have a lot of duplicate paths in this geometry. If you middle mouse in here, it looks like we only have 6 unique paths, when this is actually made of lots of individual pieces, far more than 6 pieces. And now to create individual pieces that we can directly process, we need to convert this packed geometry into regular polygons. If you middle mouse, you'll see this is made of 6 packed alembics. And packed geometries are essentially like boxes that can contain any number of polygons within them. And packed geometry can contain more than raw polygons, but just think of it for now as a container for geometry. Now to get the actual polygons from those containers of geometry, we can use the unpack node and connect our non-glass geom to that. And you'll see now this contains 6 poly soups. And we don't need to get too deep into what poly soups are now, but that's just another way to store polygon data. It's a bit more efficient than just raw polygons for certain workflows. But in this case, we just want the actual polys themselves. So you can drop in a convert node, connect that to our unpack, and by default the convert is set to convert our incoming geo to regular polygons. And you can see now we have all 41,000 polys. Now, although we have all of our raw geometry, you can see we don't have our path attribute. So anytime you get the actual geometry from its packed containers, if there are any attributes that you want to inherit from the containers, we need to specify that in the unpack node. So under transfer attributes, we'll go to the drop down and select path so that all these polys inherit that path attribute from those packed containers. Now, as I mentioned, we have this geometry broken up into lots of pieces, but it's actually only registering as 6 different paths. So we're going to give each of these paths a suffix so that we can select just one piece of geometry at a time based on its connectivity to any other pieces. So if we drop in this connectivity node, we already looked at this connectivity in week 1. We're going to set this to primitive because we're adding this to a primitive attribute, and that will give us a value for each connected mesh in the geometry. And then you can drop in a primitive wrangle, and I'm going to rename this to say what it's doing, call it unique paths, and then within this wrangle we can take the path string, so s at path, and we'll say plus equals to append an extra string at the end, and I'll say slash section underscore, and then close that quote, and then we'll just add that class value. So I to a to get the integer converted to a string, and pass in the integer at class. And then once we've built those unique paths, we don't need that class attribute anymore, so we can drop in an attribute delete to keep our geometry nice and clean, and we'll select that class attribute to remove it. Now if you middle mouse on this attribute delete, you can see we now have 607 unique paths, so it's one for each individual piece of geo. And if you go to your selection based on paths, this is still one big piece. It's a little bit hard to see with these selection colors. If you turn off selection colors with this icon, it can sometimes be easier to see. So you can see that's one piece, but all of these are now individual pieces. All of the window frames are isolated, and so on. Now, one of the important steps of prepping our building for fracturing is selecting the pieces that we don't want to fracture, perhaps they're out of camera, and splitting those out, because it's a real waste to run high resolution fractures on the pieces that we won't really see. So make sure that attribute delete is displayed and selected, and we'll go to our primitive selection based on the path attribute in our viewport, and we'll start selecting these pieces, perhaps those two at the top, and down at the bottom, maybe we don't need these sections. And then with those selected, you can tab in the viewport, type in split, and split out those selected pieces. Let's create a null for that. We'll call this out building untouched geom. Maybe rename the split untouched geom. So now that we have the untouched geometry isolated, let's create another null to view the second output of that split. Maybe call this to fracture. And then we can start isolating each section of the geometry to check to see if it's well suited for fracturing. Now this can be a very time-consuming process. This is always a bit of an annoying step in production. Even at the big studios, it's not like we get every model in a perfect state. There's always a lot of debugging we have to do on every asset that we start to chop up. I mentioned some of the problems to watch out for in week 1. Some of those I don't usually check for, like the normals being consistent and that sort of thing, unless I start running into actual fracture problems. But one of the things that I absolutely check for right away is unshared edges to help detect planar geometry and to see if there are any holes in geometry that looks solid. Now it helps to split this up into logical sections before we start checking this. And if you check the spreadsheet and look at that path attribute, you can see that we have some more hints in here about some logical ways to split this up. We have a whole bunch of objects tagged with BLK metal, presumably black metal, although you don't have to render it that way for your projects. We have concrete sections, we have interior shape, concrete NCL1, and so on. Now I'll save you the trouble of trying to figure out how to split up this into logical sections, and I'll give you a few path substrings to look for to enter into the split nodes yourself. The first split we'll create will be for the interior geometry. So we'll hook that up, call the split interior, and we'll enter path equals interior shape. We can put in a null to view that there. You can see already that the interior is planar geometry, but we will fix that later. Then to split up these exterior ring sections, we'll drop in another split, and in this one we'll enter concrete mix underscore NCL1, and that will give you these skinny little rings like so. Call that split rings. For the remainder of the exterior, we'll drop in another split, and this one will just base on concrete mix shape. And that will give us this large exterior section here. And we can move on to these so-called BLK metal rings. Well, let's rename that other split to exterior first, split exterior, and then create another one. Connect that up. This will be for another set of rings, and you can use the string BLK metal underscore NCL1 underscore 1 for that. And then finally, all we have left at the end are the window frames, and you can drop in a null and call this window frames, like so. And let's check that to make sure it looks correct. And unfortunately, it looks like this isn't isolating only the window frames at the end. It looks like we're getting some of the same geometry as we're getting in that previous split rings. Now this is something you really need to watch out for. It's a common bug in Houdini that's been going on for quite a while, and there are various things internally that can cause this, so they're always kind of fixing various causes of this ghosting geometry issue. But anytime that it seems like there's geometry in the viewport that shouldn't be there, it might not actually be there on this, this null that we're displaying. It might be just kind of ghosted old geometry that's stuck. Now one quick fix for that stuck geometry is to go to the render view tab and back. If that doesn't work, then you could delete your scene view tab here with a little X and just create a new one. And if that doesn't work, it's probably real geometry that you're seeing, and you can debug to see if you've done something wrong, then just to make sure that it's not a display issue versus a real issue in your setup. In any case, now we have our various sections working correctly, now that we can actually display them properly, and we can move on to looking at each section and fixing the parts that need to be fixed.